Alright, so let's finish off the questions that we didn't complete the last time. So this is probably part 2 for tangents and normals. So question 9. Question 9. So the normal to this curve. So y is given to be 6 divided by square root of x minus 2. Alright, so dy by dx is going to be 6 d by dx of x minus 2 to the power minus half, right? So I just factored out this 6, and then I have d by dx of 1 over square root of x minus 2. And this one I can write as x minus 2 to the power negative half. So I hope the simplification made sense. So now if I differentiate this, I bring negative half to the front. I have x minus 2 to the power negative 3 by 2, right? I think so. Yeah, negative 3 by 2. And this is not x, so if I differentiate it again, I'm going to get 1. And times 1, basically it's going to be the same thing. So I have minus 3 divided by x minus 2 to the power 3 over 2. This is my final expression here, I believe. Yeah, alright. So now we can substitute x is equal to 3, right? We need to find this at x is equal to 3. So negative 3 divided by 3 minus 2, this is going to give me 1. So the slope of my tangent line is negative 3. If you find the slope of your normal line, that is going to be 1 over 3. Why? Because slope of your normal line is negative 1 over slope of your tangent line, right? So it's 1 over 3. So now that we know that it's 1 over 3, we can find the equation of our normal line. So y minus y1 is going to be m normal x minus x1. So y minus 6 is the slope of your normal line is 1 over 3. X minus 3. And now if I multiply by 3 on both sides, I get 3y minus 18 is equal to x minus 3. So 3y minus x is going to be 15. So that is going to be the equation of your normal line. So now it says that the normal line, this normal line, meets the x-axis at p. That means if it's meeting the x-axis, then my y value has to be 0. And if your y value is 0, you will see that x is negative 15. So you have negative 15, comma 0. So that is where it meets. So if you put 0 here, right? If x is equal to 0, if y is equal to 0, then x is negative 15 using this equation. And if it's meeting the y-axis, then x has to be 0. So if x is 0, y is 5. So you have this line. This is your normal line, right? So this is P, this is Q. And we need to find the midpoint. So the midpoint is just going to be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. And you know that x1 is 15, x2 is 0, so negative 7.5, right? If you plug those values here, you're going to get negative 7.5. And this is y2 is 5, y1 is 0. So 5 plus 0 is just 5 divided by 2. That is going to give you 2.5. So that is going to be your midpoint, negative 7.5, comma 2.5. And we are done with question 9. All right. So now before I move on, let me just show you something very quickly. So let's go to Desmos. And we are going to plot this function, 6 divided by square root of x minus 2. 6 divided by square root of x minus 2. All right. And now let's plot the normal line, right? So the normal line is... So the normal equation of the normal line is going to be y is equal to x plus 15 divided by 3. And equation of the tangent line, if you use this, is going to be... So this is the equation of the normal line. If I want to find the equation of the tangent line, then I would substitute negative 3, right? Negative 3x minus 3. So that gives me y minus 6 minus 3x plus 9. So y is equal to negative 3x plus 15. All right. So this is my normal line. This is my tangent line. So x plus 15 divided by 3. So x plus 15, sorry. So x plus, oh my god. Okay, so x plus 15 divided by 3, and the other is minus 3x plus 15, right? Okay, minus 3x plus 15. So if you see this, both of these lines intersect at 3, 6. That was the point given to us. And the purple line so the purple line is the tangent line, the green line is the normal line. They intersect each other at 90 degrees, right? So this angle here, this angle, unfortunately I can't like right on top, but you can see that at this point they form this 90, the purple line and the green line. So if I switch off this, they make a 90-degree angle. And basically we used this point, we figured these points out, and then we found their midpoint. So that is what we had done in this question. All right, so let's move on to question 10. Question 10, a curve has this equation. So the normal at this point and the tangent at this point intersect at point R. Okay, so let's just find dy by, so y is x to the power 5 minus 8x to the power 3 plus 16x. So our first point is 1, 9. And they said that the normal at this point, so let's find the equation of the normal at this point. So we can find dy by dx. If I differentiate this, I'm going to get 5x to the power 4 minus 24x squared plus 16, right? And if I put x is equal to 1, then I get 5 minus 24 plus 16. That is negative 3, I think. 5 minus 24 plus 16. It is negative 3. So this is the slope of the tangent line at this point. This is the slope of the tangent line at this point. So find the slope of the normal line, we do negative 1 over mt. And if you solve this, you are going to get 1 over 3. All right. So now you can find the equation of the normal line. Of the normal is going to be y minus, what is y1? y1 is 9. And the slope of the normal line is 1 over 3. X minus x1 is positive 1. If I multiply by 3 on both sides, this and this is going to cancel out. So I get 3y minus 27 is x minus 1. So 3y is equal to x plus 26. So that is my equation of the normal line. All right. So now the second point we are given is that the tangent at this point. So q is minus 1 comma minus 9, I think. Yeah. And we want to find the tangent. We already know what dy by dx is. dy by dx is this expression. So we want to substitute x is equal to minus 1, right? Into this expression, so we have dy by dx is equal to 5x to the power 4 minus 24x squared plus 16. And we want to substitute x is equal to negative 1. And that gives us the tangent, slope of the tangent line at this point. So you are going to get 5 minus 24 plus 16 if you substitute negative 1. And that is going to be negative 3 again, I think. Yeah, negative 3. So equation of the tangent line is y minus y1 equal to mtx minus x1. So y1 is negative 9. So y minus or minus 9, y plus 9 minus 3 x plus 1. X minus or minus 1 is going to give you positive. So y plus 9 is minus 3x minus 3. And y is minus 3x plus 6. All right. So now we have equation 1 and equation 2. And we want to find the point of intersection of these two equations. So I can just substitute the value of y here, right? 3, y is minus 3x plus 6 is equal to x plus 26. And now we get minus 9x plus 6 3s are 18 is equal to x plus 26. And if you simplify, you are going to get minus 10x is equal to 26 minus 18. That is negative 8. And x is going to be, sorry, positive 8, right? 26 minus 18, positive 8. So x is going to give, so if you solve the equation, you are going to get this value for your x. 8 divided by negative 10 is negative 0.8. It seems that I have made a mistake somewhere. Six 3 is 18 is equal to x plus 26. 26 minus 18 is 8. And minus 9x minus x is minus 10x. So x is equal to negative 0.8. Let us see. So I'm trying to spot the mistake here. Here. So I made a mistake here. Sorry. Okay, here's the mistake. I made a mistake when simplifying this. So y is equal to negative 3x minus 12, right? You have to subtract 9 from both sides. I was like, okay, where did I make the mistake? Okay, here. So now you substitute this here. So 3, your y is minus 3x minus 12, x plus 26. You have minus 9x minus 36. Minus 10x is going to be 36 plus 26. 62. If you add 36 to both sides. So x, you're going to get negative 6.2. Okay, so now we are correct. So I made a mistake here, and I hope you caught that. Okay, so x is negative 6.2, and you can just plug in this value of x into any equation. So y is going to be minus 3 minus 6.2 minus 12. So when you solve this, minus 12, you get 6.6. So your coordinates is negative 6.2 comma 6.6. That is the point R that we are looking for. All right, moving on to question 11. So this is the point R. Moving on to question 11. Okay. I'm so sorry. Okay. A curve has this equation. So y is equal to 2 square root of x minus 1 cubed plus 2. So normal at point P. So P is 4, 4. And you have Q is 9, 18. And basically we want the normal of the two curves. Okay. 9, 18, 4, 4. So let's find the equation of the normal at the 2 points. So dy by dx is going to be 2 times d by dx of square root of x minus 1 to the power 3. And if you differentiate this part, you're going to get 0, right? So plus 0 does not matter. So 2, you bring this 3 down, square root of x minus 1 squared, 3 minus 1 is 2, but ani x dega made, so you have to differentiate it again. Alright, so you have 6 square root of x minus 1 squared, and this, if you differentiate, you are going to get, so I'm going to leave the differentiation to you, but you're going to get this expression. And if you simplify, you are going to get this expression overall. 6 divided by 2 is 3, and then you have this in the numerator, and you have this in the denominator. All right. So now you want to substitute this point here. So now the slope of the tangent line when x is equal to 4, right? That is the first coordinate. If you substitute 4 here, you're going to get 2 minus 1 squared divided by 2, right? So that is just 3 over 2, I believe. And if you use mn, so if you substitute 4 here, this is for point P, 4, 4. So if you substitute 4 into this equation, you are going to get 3 over 2. So m of n, if you substitute it, you're going to get negative 2 over 3. And if you check, mt times mn should give you negative 1. If you multiply these two numbers, you are going to get negative 1. So slope of your normal line is this. Now you can find y minus y1, mn x minus x1. So y minus 4 is equal to negative 2 over 3 x minus 4. And if I multiply by 3 on both sides, I am going to get this expression. And if I distribute negative 2 inside, I have 3y minus 12 is equal to minus 2x plus 8. And so 3y plus 2x, right, if I bring this here and if I bring that there, is 20. So that is the equation of my normal line at the point P 4, 4. Now we need to do it again, but for this point, right? So when dy by dx is equal to 3 square root of x minus 1 squared divided by square root of x, now I substitute 9 here. If I substitute 9, I have square root of 9 is 3 minus 1 squared. Square root of 9 in the denominator is 3. So this is going to cancel out. I am going to get 4, right? So that is the slope of the tangent line. The slope of the normal line is going to be minus 1 over 4. So y minus 18, y1, should be equal to negative 1 over 4, x minus 9, right? Okay, so now I can multiply by 4 on both sides, and I am going to get this expression. If I simplify, and I'll leave the simplification to you, but you are going to get 4y plus x is equal to 81. All right, so now we need to find the point of intersection, right? Yeah, find the coordinates of r, and r is the point of intersection. So now we want to find, so we know that 4y plus x. So if I multiply this equation by 2, I am going to get 8y plus 2x is equal to 162. And I have 3y plus 2x is equal to 20. So if I subtract both equations, I have 8y minus 3y is 5y, 2x minus 2x is 0. So this, when I simplify, so I'll leave you to solve the system of linear equations on your own. So I will get 142. And y is 142 divided by 5. That is 28.4. All right, so y is 28.4, and then I can substitute y here to get x. So 4 times 28.4 plus x is equal to 81. So if you solve this equation, you get x is equal to negative 32.6. So that is the coordinates of your r. Your r point has the coordinates negative 32.6, comma 28.4. Okay. So now we need to find the area of this. All right. So this is probably going to be like pieced together by CapCut to the other videos. So you may find like some disruption or just like abruptly, but things erased and stuff like that. But we found the coordinates of r here. So now we need to find the area of this triangle. So now, embarrassingly, I did try this question and I failed because I was thinking of using methods that we have not discussed before. So I used the dot product and the cross product, and they gave me the answer. If you use the dot product, you only get an approximation. It's quite close to the actual answer, but you don't get the exact answer. If you use the cross product, you get the exact answer. But there turns out there is a simpler way, a far, far simpler way that I did not think about. So that is, I'm going to show you that here. So you have P, you have Q, which is 9, 18, and you have R. So R is somewhere over here, negative 32.6, comma 28.4. All right, so we have P, Q, and R. So now you connect these 3 points to form a triangle. So now you could think of using vectors, you could think of using the cross product, which is where my thoughts went first as well. But turns out there is a simpler solution. And the simpler solution is, let me just construct a rectangle outside. So I am just going to construct this sorry about that. I'm just going to construct this rectangle. Oh my god. Okay. Something like this, this, Okay, it doesn't work. Let me just draw it freehand. And something like this. So now how does this rectangle help me figure out the area of the triangle? Well, I can find out the area of the whole thing, and I can subtract out the green part. And remember, the green part is just the area of 3 right-angled triangle, which we know how to find. So that is what we are going to do. So first of all, let's find the area of rectangle. We'll call this triangle 1, this 2, and this 3. 3, 2, 1. Okay, so area of the rectangle is just base times height. So what is the base? 4. Well, starting from 0, so this is 0. This point is x0, right? When you go to here, you get to x9. When you go to here, you were at x negative 32.6. So I hope that is clear, right? This point has the coordinate x9 negative 32.6. So the total length, so I'll just take the total length is I have negative 32.6 units here and 9 units here. So I'm going to ignore the sign and I get 32.6. So negative 32.6 just means that from 0, I go negative 32.6 units to the left, right? So I don't care about the sign of the x-coordinate, but I just need to know that I go 32.6 units. Negative just means I'm going to the left. Plus 9 to the right, right? That is my base. Now let's think about the height. I start from 4. I go to 18. So I start from 4 and then I go up to 28.4. So I actually go up 24.4 units. Think about it. 4 to 28.4, that is just going to be a simple subtraction to find out the height. Right? 28.4 minus 4 is 24.4. So area of the rectangle is going to be this is going to be 1015.04, I think, if I did it correctly. I think it is. All right. So that is the area of the triangle. Now find area of the triangle 1. That is going to be half. What is my base? My base is this length, which is 32.6, plus this length as well, 4. And what is my height? My height is just this height. And it's just the same height of the rectangle that we considered, 24.4. So if you do this calculation, you are going to get 446.52. Let's find area of triangle 2. It's again half. My base is going to be this. So 4, starting from x is equal to 4 up until x is equal to 9. So that is a distance of 5, right? 9 minus 4 gives me 5. And a height from starting from 4 all the way up until 18. So 18 minus 4, that is a height of 14 units. So 5 times 14 divided by 2, that is 35. An area of triangle 3 here. So what is my height? My height starts from 18, goes to 28.4. So half, my height is 28.4 minus 18. And my base is going to be this long side. It's going to be the base of the rectangle, which is 32.6 plus 9. And if you calculate this, you are going to get 32.6 plus 9. So you are going to get 216.32. So now your area of your triangle in question is going to be the area of the rectangle minus the sum of the area of triangle 1 plus area of triangle 2 plus area of triangle 3. Right? You add these 3 together and you take it away from the rectangle and you are going to get the area of the pink triangle that we wanted. So rectangle is 1015.04 minus triangle 1 is 446.52 plus triangle 2 is 35 plus triangle 3 is 216.32. So now we can solve this as 446.52 plus 35 plus 216. So if you solve this using your calculator, you get 317.2 square units. All right, so that is your final answer. I know, very unusual, but that gives you the correct answer, and using just geometry. All right, so we are done with question 11.
Voila. It's always hello.
Let's erase this. Question 12. So a curve has this equation and passes through these 2 points. So we have point C and D on the curve. The tangent is parallel to AB. So now let's find AB. The line AB, the slope of the line AB, right? The slope of the line AB is going to be y2. So let's just pick this to be y2 minus y1 over x2 minus x1. So that is 8 by 4, which is 2. And let's just visualize this. We have some point A, we have some point B. This is a straight line. So we can do y2 minus y1 over x2 minus x1 to calculate the slope, right? That is something that we have been doing before. So slope of this line, AB, is going to be 2. All right. So now we know this. So it says that the tangent is parallel. That means that the tangent line and the line AB have the same slope. So let's find dy by dx first. That is going to be d by dx of the expression 3x plus 12 over x. And if you differentiate it, you are going to get 3 minus 12 over x squared. And we want to make sure that this dy by dx is equal to 2, right? Slope has to be parallel to the slope of AB. That means they have the same slope. So if two lines are parallel, they have the same slope. So now I multiply by x squared everywhere. I get this expression. So now if I rearrange, I get this expression. And therefore my x is going to be plus or minus the square root of 12, right? If I take the negative and I square it, I still get 12. If I take the positive and I square it, I still get 12. So I could write this as plus or minus 2 root 3. That is also okay. All right. So it says find the coordinates of the point C and D. So let's just say C has the coordinate positive 2 root 3. And if I substitute positive 2 root 3 into this equation, right? So y is equal to 3 times x is 2 root 3 plus 12 over 2 root 3. So if you simplify this, you're going to get 6 root 3 plus 6 over root 3. That is going to be 6 root 3 plus, if I multiply and I divide by root 3, then I'm going to get 2 root 3, I believe. That is going to be 8 root 3. That is one value. So 2 root 3 comma 8 root 3, that is going to be my point C. Let's say negative 2 root 3 is my point D. All right. Negative 2 root 3. Now, if I substitute negative 2 root 3 into this equation, 3 times x, so negative 2 root 3 plus 12 divided by negative 2 root 3, I am going to get negative 6 root 3 minus 6 over root 3 times root 3 by root 3, and this simplifies to 3, so minus 2 root 3. So I'm just going to be like this. So you are going to get these 2 points for C and D. All right. Now we need to find the equation of the perpendicular bisector of CD. So basically you have point C here, you have point... Okay, it looks like you have point D here, you have point C here, based on the coordinates. So now you want to find the equation of the perpendicular bisector. So the perpendicular bisector looks something like this pink line. It has two conditions. It must intersect CD at 90 degrees, and it must pass through the midpoint. So let's find the midpoint of CD. So midpoint of CD is going to be, you add these two together and you divide by 2. And if you do so, you are going to get 0. You add these two together, you divide by 2, you are going to get 0 again, right? x1 plus x2 divided by 2 is going to give you 0. y1 plus y2 divided by 2 is going to give you 0. So the midpoint is going to be 0, 0. So this midpoint is going to be 0, 0. Now another thing is that let's find the slope of CD. So the slope of CD, so this pink line is just gonna have, because it's perpendicular lines, they must satisfy this m of CD times m of this new pink line must be equal to -1, right? So we are going to use that. So now we need to find slope of CD. That is going to be y2 minus y1. So let's pick this y2, this is y1, so you're going to get 16 root 3. This is y2 minus y1 is going to give you this. x2 minus x1 is going to give you 4 root 3. And that is just going to be 4. So now the line equation of the normal line, so MCD times m of this perpendicular bisector is going to have to be -1 because they intersect at 90 degrees. So m of this perpendicular bisector has to be -1/4. And now we can finally make the equation. Y minus y1 is m perpendicular x minus x1. And remember, y1 and x1, they pass through the midpoint, so these are going to be 0. So it's just -1/4x. That is my final answer. So I hope this made sense. But you can also rewrite it as 4y is equal to -x, right? If you multiply by 4, so 4y plus x is equal to 0. Or this is the same thing. We are done with question 12. Question 13. Okay. This is a curve. It crosses the x-axis at these points. Okay. So the normals to the curve at point A and B meet at the point C. So find the coordinates. Okay, so we have this curve, right? It's x minus 1, x plus 2. So rather than using the product rule, it's easier if you just expand everything out. We get x squared minus x from the first if I expand this out, and I have x plus 2. If I simplify this, I get x cubed plus 2x squared minus x squared minus 2x. If I simplify everything. So I am going to get x cubed plus x squared minus 2x. And this enables me to find dy by dx very easily. It's going to be 3x squared plus 2x minus 2. Alright. So now we have the normals to the point at point A and point B. A is 1, 0. B is -2, 0. So let's find the normal at point A. Normal at point A. So now find dy by dx at point A is x is equal to 1. So that is going to be 3 times 1 squared plus 2 times 1 minus 2. So that is 3 plus 2 minus 2. So that is just 3. But this is, remember, slope of the tangent. So slope of the normal is going to be -1 over slope of the tangent, so -1/3. Now we can find the equation. Y minus y1 is 0. M of the normal line, x minus 1. Right? Using the point A. We are just dealing with the point A here. I have y is equal to -3x plus 1/3. Right? And yeah, that is it. That is going to be the equation of my normal line in this case. Now let's do this n at point B. So dy by dx, but instead of x -1, I'm going to substitute x is equal to +1. It's going to be -2. And it's going to be 3 minus 2 squared plus 2 minus 2 minus 2. Right? I substituted here. So I'm going to get 12 minus 4 minus 2. That is going to give me 6. But remember, this is the slope of the tangent line. The slope of the normal line is going to be -1/6 if you use the formula. So now equation of the normal line passing through B is going to be y minus 0 again, right? Because this is 0, is equal to -1/6 x minus, and x1 is just -2, so x plus 2. So y is going to be -1/6 x minus 1/3. So that is the equation of the normal line passing through B. Okay. So the normals of the line A and B meet at point C. Find the coordinates of point C. So we just want to equate these two lines together. So -1/3x plus 1/3 is equal to -1/6x minus 1/3. If I bring this here, Actually, let me take this here and I take this here. I'm going to get 2 over 3 is going to be 1 over 6x, I think. If you simplify, I'll leave you to simplify this. 12 over 3 is going to be x, therefore x is equal to 4. And if I substitute 4 here, y is going to be negative 4 over 6 minus 1 over 3. So negative 2 over 3 minus 1 over 3 is negative 1. So therefore, you are going to get the point 4 comma negative 1. That is going to be your coordinates of the point C. So I know I did things a bit quickly, but I think you should be able to understand it. That is going to be the solution. All right. That took shorter than I expected. Question 14. A curve has this equation, passes through this point. Basically, the simple equation of the tangent line. So y is equal to 5, 2 minus 3x at the point negative 1 comma 1. So let's write this as 5 times 2 minus 3x to the power negative 1, right? It's the same thing. Now, this makes it easier for me to calculate dy by dx. So it's going to be 5 d by dx of 2 minus 3x to the power minus 1. So that is going to be 5 minus 1, 2 minus 3x to the power negative 2. But ani x dega, made, so you have to differentiate it again. 2 minus 3x. So now, this is going to give you minus 5 divided by 2 minus 3x squared. And if you differentiate this, you're going to get a minus 3. Right? So you get 15 over 2 minus 3x squared. Okay. Now we need to evaluate this at negative 1. X is equal to negative 1, right? At this x value. So the slope of the tangent line at negative 1 comma 1 is going to be 15. If I substitute negative 1 here, I'm going to get 5 squared. 2 plus 3 is going to give me 5. And that is going to be 15 over 25. 15 over 25, remember, is going to be 3 over 5. So now, y minus y1 is 1 is equal to 3 over 5, slope of the tangent, x plus 1. X minus x1 is going to give me, x minus or minus 1 is going to give me x plus 1. So y minus 1 is 3 over 5x plus 3 over 5. And if I add 1 on both sides, I get 8 over 5 plus 5 over 5. So that is just going to be 0.6x plus and 8 over 5, 1.6. That is going to be your solution. Yep, this is it. So find the equation of the tangent to the curve at P. Yep, this is it. This is the equation. We're done with 14. Also took shorter than I expected. Okay, we're almost done. Question 15. We have this curve. It intersects the x-axis at point P. That means we have to solve for y is equal to 0. So you solve for y is equal to 0. If it's intersecting the x-axis, then it's y. We are solving for y is equal to 0. Add 4 on both sides. Divide by 4 on both sides. You're going to get this expression. So I hope you can figure out. I divided by 4 on both sides, I get this expression. So I know 2x minus 3. If I multiply it here, I'm going to get it 3. 2x is equal to 6. X is equal to 3. All right. So now, this point P is going to be 3 comma 0, right? Because it's intersecting the x-axis here. So if you substitute 3 here, you should get 0. And you do. 3 2 is 6 minus 3 is 3. 12 by 3 is 4. 4 minus 4 is 0. So the tangent to the curve at P. So we want to find dy by dx. And that is just d by dx of this expression. 12 over 2x minus 3 minus 4. And you differentiate it, you are going to get... So this differentiates, minus 4 differentiates to 0. Ignore it. So you have 12 d by dx of 2x minus 3 to the power negative 1, right? We just need to differentiate the first part. So now use the power rule. Negative 1, 2x minus 3 to the power minus 2. But ani x dega mave. So you have to differentiate it again. And now you get negative 12. Annually, you get 2. And then in the denominator, you get this expression.
好啊
So you have negative 24 over 2x minus 3 squared. Alright. And now I need to substitute at P, the tangent to the curve at P. So I need to substitute x is equal to 3. So now the slope of the tangent line is going to be minus 24. If I substitute 3 here, 3 to the 6 minus 3 is 3 squared is 9. So I'm going to get 9 is just 3 times 3. 24 is 8 times 3. So that is going to be negative 8 by 3. So it says tangent to the curve intersects the y-axis at Q. Alright, so let's find the equation of the tangent. Y minus P, y1, is 0, right? Is equal to slope of the tangent, x minus x1 is 3.
哦，那个
Using this point P, we are going to find the equation of the tangent line. So that gives me negative 8 over 3x plus 8. That is the equation of the tangent line. And this tangent line intersects the y-axis. That means x is equal to 0. So y is equal to 8. So 0, 8 is your point Q. So now let's plot these 2 points. So 0, 8
兄弟
is point Q. And point P is 3, 0. 3, 0. And we want to find this distance. Well, that is just Pythagorean theorem. This is 3, this is 8. So the length, PQ, is going to be the square root of 3a squared plus b squared. C squared is just a squared plus b squared, right? So C is square root of a squared plus b squared. So now that is just using the Pythagorean theorem. We just get square root of 73. That is PQ. And we are done. Alright. Exhausted. One more. Question 16. The normal to this curve at this point is parallel to this line. Okay. Let's find dy by dx. So dy by dx gives me 4x plus k, right? K is a constant, differentiate x, you get 1, differentiate negative 3, you get 0, so you are going to get this expression. And now we want to find the normal at this point. The slope of the tangent at point P, which is going to be 3, negative 6. So you just substitute 3 here, right? So that is going to be 12 plus k. So slope of the normal is going to be negative 1 over 12 plus k. Alright. Is parallel to this line. Well, x plus 5y is equal to 10. 5y is equal to negative x plus 10, right? If I send x to the other side, y is equal to negative 1 over 5x plus 2. This is the slope of this line. So this slope, if it's parallel, then the slopes have to be equal. If two lines are parallel, their slopes must be equal. So now these negative signs cancel out. I get 5 is equal to 12 plus k if I cross multiply on both sides. And similarly, I get k is equal to 7. Sorry, no, k is equal to negative 7. So I have to subtract 12 on both sides. And you get k is equal to negative 7. And find the coordinates of the point where the curve... Now for part B, now that we know that k is negative 7, m of n is just going to be 12 plus minus 7. So that is going to give me 5. So we know that the normal has this gradient. Alright, so y minus y1, let's find the equation of the normal. X minus x1. So which point does this normal pass through? This point. So y plus 6 minus 6 is going to give me plus 6. X minus 3, I believe, right? So now if I multiply by 5 on both sides, I get 5y plus 30 is equal to 3 minus x, I believe. So I have 5y plus x is equal to negative 27. I think that is the equation. I believe it is. Alright. So we know that this is the equation of the normal. And the equation of the curve is going to be y is equal to 2x squared minus 7x, because k is negative 7, minus 3. So substitute this value of y here. 5, 2x squared minus 7x minus 3 plus x is negative 27. So you get 10x squared minus 35x minus 15 plus x, negative 27. That is 10x squared minus 34x. And then you have minus 15 plus 27.
What the fuck?
That is 12. That is going to be 0. So now let's solve this quadratic equation. If you divide by 2, you get 5x squared minus 17x plus 6. So your sum is negative 17. Your product is 30. And your two numbers are quite easy to figure out. It's going to be negative 15 and negative 2. So 5x squared minus 15x minus 2x plus 6 is 0. You factor out a 5x, you get x minus 3. You factor out a minus 2, you get x minus 3 as well. And so it's going to be x minus 3, 5x minus 2 equals to 0. So we already know x is equal to 3. We already know this point. So we will solve for the other point. So 5x minus 2 is equal to 0. X is going to be 2 over 5. And now that x is equal to 2 over 5, we just need to solve for y, right? So just plug in y here. So 5y plus x is 2 over 5 is equal to negative 27. So 5y is going to be negative 27 minus 2 over 5, right? So negative 27.4. So y is going to be negative 5.48. So this is 0.4. This is negative 5.48. So your coordinates are going to be 0.4 comma negative 5.48. And we are done. Finally. All right. That is your solution for 16. I hope this was clear.